This is the anti-gravity water experiment. Okay, so what do we need for this one? I recommend a bowl, or actually if you're doing this at home, over the kitchen sink, brilliant place to do this. But if you're going to do it in a sort of place where I am, where there's no kitchen sink, I recommend a bowl, or possibly even better still, a bucket, a deep bucket. I'm using a bowl because I want you to be able to see what happens more easily, okay? You need a cup. Now I'm using a glass for this because again, I want you to see what's happening, but I actually recommend you using something perhaps like this, just a plastic cup, because it is quite possible in this particular experiment you might more easily drop it than some of the others I do, and obviously dropping glass isn't much fun. So having a plastic cup's better. This would be good, but I'm not using this, I'm going to use a glass for this experiment. You can see here I'm using a piece of plastic. Now, I will say straight away that there are some alternatives which I think you could consider, especially since many of you may not have a piece of plastic exactly like this one. So really what I want you to find is something that's nice and flat that you could rest on top of the cup. Something that's just a bit bigger than the mouth of the cup, or glass in this case, and this is slightly bigger, not much bigger actually, but it's just a bit bigger for me, okay? So maybe a square of material, it could be a piece of cardboard, might be worth trying. And again, I'm giving you these as variables right now. Maybe you can actually find the lid of a container at home from maybe a plastic box or something like that. But something that's flat that you can rest it on the top like this. Something, make sure though that whatever it is doesn't get too soggy or waterlogged if water goes on it. So obviously that's one of the reasons I like using plastic. You need some water, and as you can see I've got some water in a jug. Now this is the first part of what we've got to do, and by the way, this can get a bit messy with the water. If you do it in a kitchen over a sink, obviously near the sink, that gets water there all the time. But if you're going to do it on a table or somewhere like I'm doing it where there's no sink around, I do recommend having some kitchen towel on hand just so you can wipe things up afterwards. So here we go. Pour some water into the glass. Now what I want you to do for this particular experiment is fill it right to the top. Right to the top. Okay, we could get a bit more. Let's try a bit more. Not much more. Okay, so as near as you can get it to the top without it spilling over. Then I want you to place whatever you're going to use. I'm going to use my plastic piece here. Just rest it on top. Now notice this isn't sticky. There's nothing sticky about it. This is totally clean and dry. No stickiness in sight. So I want you to notice that. This is definitely not sticky, okay? You're going to see why I'm saying that in a minute. I'm going to move this out of the way, because then I want you to move your bowl, if you're using a bowl, in front of you like this. Remember, you could be over the sink, in which case you'll be doing it into the sink. I want you to press your finger down quite firmly on the thing that you're using. So if you're using a piece of plastic, press firmly on it. Lift it up into the air, over your bowl or sink, keeping your fingers firmly in place. Turn it upside down, okay? And then take your fingers away and see what happens. Right, let's see what happens for mine. Not much. Now remember, this is not sticky. Some came out then, but look, not sticky. Try the other way, just in case you think there's something going on there that I haven't told you. Works both ways, doesn't matter which way round. Now let me shake it a bit, see if I can shake it off. See how much force I need to shake it off. This is where the mess can start, by the way. So now of course I can't measure the force I'm using. Actually, let's make this a bit more fun. I'm going to top it right back up again. I always think it's far more interesting when it's totally full. At least when I first do it. So let's turn it back upside down. So pretty much full, there's a little bubble in the top, but I think otherwise it's as full as I can get it. Take my hand away. Now I'm going to shake it. Now of course you can't see how hard I'm shaking it other than watching what I'm doing, so I can't actually measure the force I'm using, in other words, but watch carefully, and of course I want you to do the same thing afterwards to see what it feels like to you. So shake, 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 shake. But did you notice how hard I had to shake to get it off? I was really shaking hard. And even then it wasn't coming off. It was a good few goes before it came off. So what's going on here? So how come the water appeared to have an anti-gravity effect? It stayed up in the glass. Why didn't it come out when we had the lid on initially anyway, before I gave it a really hard shake? What was keeping the lid on is an obvious question. Well, a couple of things to think about. First of all, we know that water weighs something, of course. So the weight of the water was being pulled down by gravity. That's probably why you were quite surprised it didn't come out in the first place. Why wasn't gravity pulling it down? Well, gravity was pulling it down, so the question is why wasn't it actually responding and coming down in that direction initially? Why didn't it fall straight off? It's got a lot to do with the air around us in this room here and right now. The air is pushing against everything. The air weighs something, made of atoms and molecules, so it must weigh something. Gravity's pulling the air too, and the air pushes on things all the time. And it pushes on with a pressure. We call it atmospheric pressure. So atmospheric pressure is the pressure caused by the pushing of the air on surfaces because of its weight. And the air is pushing on everything, and it was pushing up under that plate that I had on here, that disc, whatever you're going to use, was pushing against it and keeping it on here. Even though the weight of the water was really heavy, it wasn't enough to push the air out of the way that was pushing and holding that disc on in place like that. One other factor to consider. Where this was on, I'm just going to replace it here just for a second. Where it was on there, remember when the glass had lots of water in it, some of that water would have been seeping around the edges. But where it appeared outside to the air, if you like, as soon as it met the air, a layer would form called a meniscus. And it's that meniscus layer where the water meets the air, where the water actually pulls on itself in a rather interesting way and forms like a skin of sorts, like a watery skin. And it has some properties. It has what we call surface tension. It pulls in all directions. And that watery skin was stopping the water from escaping anymore, and it was allowing the air to push up against it as well. And that's another factor as to why the water didn't leak out. And you saw how much pressure I had to use. Again, we couldn't measure it, you were just watching me. But I think you'll agree, I was shaking pretty hard before it finally came off. And you know, sometimes I can shake it really hard and it doesn't come off at all. So in fact, you're quite lucky to see that one come off. Sometimes I've shaken and shaken and shaken and shaken and it doesn't come off at all. So it sometimes depends on other things. But you just saw right now what happens in its simplest form, and I hope the same thing happens for you. So let's think of a few things we might choose to change. Well, I've already hinted at one of them in the instructions, didn't I? I said, how about using something different from this disc or this small plastic plate, whatever you want to call it. I've used this one because it allowed you to see through it and it was easy for me to use. But what about cardboard? What about other plastic? What about a lid? What about something that's not rigid like this? For example, you can get plastic, which is quite flexible. How about that? Would that work, I wonder? Or does it have to be rigid to work? What about the container? Well, I've already mentioned that you could have used something like that, but notice the size of this container, so vary the size. How about using a much bigger container? These plastic cups often come in much bigger sizes, like ½ litre or even bigger I've seen. How about one of those? This is a rigid container, isn't it? Glass is rigid. That's rigid, doesn't bend very easily. How about finding a container that you sometimes get when you go out to a cafe where it's a soft material, soft carton? I wonder if that would work rather than a rigid container like this. I started this off with a full glass pretty much, didn't I? And I turned it upside down with a full glass. What would have happened if we'd done it, I wonder, with only half full? Do you think it would still work in the same way? Or a quarter or 3/4? What about some other liquids? Of course, you've got to be a bit careful with different liquids, but do you think it will still work with other liquids? What about things that aren't liquids? What if you put, for example, I don't know, something like rice or powder, maybe flour, and did the same thing? Do you think powder would have the same effect, or does it have to be a liquid? I'll leave you to think of a few more things.